Hello everyone, I am Dr. VRAO. Today I am here with another concept in electrochemistry, that is EMF of hydrogen electrode at different concentrations of H plus ions. Okay, you see you all see that heading with your naked eye with your great attention. Here I wrote EMF of hydrogen electrode. Okay, here I wrote EMF of hydrogen electrode at a different pH or at a different concentrations of H plus ions, right. Usually we can measure the EMF for a cell, right. Usually we can measure, or in fact we can measure the EMF of a cell, that is we can measure the EMF for a cell, not to an electrode, but here the heading is EMF of hydrogen electrode, right. So you should keep this point. What is that point? We can measure the EMF for a cell when there is no current is flowing in the circuit. We can measure the EMF of a cell when there is no current is flowing in the circuit. Moreover, we can measure the single electrode, and moreover we cannot measure the potential of a single electrode. From the last classes we learned that we cannot measure the potential of a single electrode potential. If we want to measure the potential of a single electrode, that should be combined with a standard hydrogen electrode and construct the cell and measure the EMF of the cell, then EMF of the cell is equal to potential of that electrode. But here I wrote EMF of hydrogen electrode. How it is possible? We can measure the EMF for a cell, but we cannot measure the EMF of an electrode. But I wrote here EMF of a hydrogen electrode. How it is possible? How it is possible? Right? It is possible by Nernst equation. Why? Because Nernst equation is applicable to single electrodes also. Nernst equation is applicable to single electrodes, and Nernst equation enable us to find EMF of a single electrode by taking E naught cell is 0, by taking E naught cell 0. Moreover, in all EMF measurements, we always use to measure, the difference of potentials, between two electrodes. Okay, so Nernst equation, in the Nernst equation, if we take E naught cell is 0, which enable us to find the EMF for a single electrode. What is that Nernst equation? Here I write the Nernst equation. E cell is equal to E naught cell minus 2.303 RT by NF log K, This is the Nernst equation, and this equation is applicable to single electrode reactions, and this equation enable us to find the EMF of single electrode by taking E naught cell 0. Why we are taking E naught cell 0? Because in EMF measurements we always measure the difference of potentials of two electrodes. That is, in measuring the EMF of a cell, we place hydrogen electrode as an anode and whose EMF is 0, and we subtract potential of that electrode minus potential of the hydrogen electrode, that is 0. We can get the EMF or the potential of that electrode, or we can finally we get the EMF of the cell, Finally, we get the EMF of the cell, and that EMF of the cell is equal to potential of that electrode. Therefore, Nernst equation is applicable to single electrodes also, and which enable us to find the EMF of the cell by taking E naught cell 0, right. So, if we by taking E naught cell 0, we can measure the EMF of hydrogen electrode, right. Now, let us calculate the EMF of hydrogen electrode at different concentrations of H plus ions. So, whatever the electrode we take, we should write the electrode reaction. What is the electrode reaction for hydrogen electrode? Hydrogen electrode undergoes reduction. 2H plus 2 electrons gives rise to H2 gas, right. This is the electrode reaction for hydrogen electrode, right. Now, we shall write the Nernst equation for this single electrode reaction, right. What is Nernst equation? E cell is equal to E naught cell minus 2.303 RT by NF log K. Here K is the equilibrium constant of the reversible electrode reaction, right, reversible electrode reaction. So, here the K is equilibrium constant of this reversible electrode reaction, right. So, this equation, Nernst equation, enable us to find the EMF of the hydrogen electrode by taking E naught cell 0, by taking E naught cell 0, okay. So, E cell is equal to, we are taking the E naught cell 0, because in always EMF measurements we are measuring the difference of potentials of two electrodes, but we are measuring the potential of or EMF of the hydrogen electrode itself. That is why we are taking E naught cell 0, right. So, E naught cell 0 minus 2.303 RT by NF. Here K is equilibrium constant, that is what is that, how can we write that equilibrium constant? Log concentration of products by concentration of reactants, that is here the product is hydrogen gas. For gases we used to express their concentrations in partial pressure. So, partial pressure of H2 gas by concentration of H plus ions, that is concentration of H plus ions, that coefficient is 2, that is why I write square, right. So, E is equal to here minus 2.303 RT by, here the number of electrons transferred is 2F, right, and log partial pressure of H2 by concentration of H plus square, right. So, we know that at 298 Kelvin 2.303 RT by F, that value 2.303 RT by F at 298 Kelvin, 2.303 RT by F, which comes out to be 0.059, right. By substituting the R value, T value and Faraday's, okay, and Faraday, we can get the 0.059. So, instead of that we can write minus 0.059, right, log partial pressure of H2. Partial pressure of H2 always equal to atmospheric pressure, that is 1 atmosphere, that is we can write partial pressure of hydrogen 1 by concentration of H plus square, right. And coming to the next step, E cell is equal to minus 0.059. Okay, I shall take this concentration of H plus ions into a numerator, that is log concentration of H plus ions inverse 2, right. So, now we can write minus 0.059, right. We can write this logarithm as minus 2 log concentration of H plus ions, right. And in the next step we can write minus 0.059 in, sorry, here is a 2, here is a 2, right, here is a 2, minus 0.059 minus, for the sake of my convenience I write this minus 2 log concentration of H plus ions as minus 2 into minus log of concentration of H plus ions by 2, right. And in the next step this 2 cancel, and 0.059 into negative logarithm of concentration of H plus ions, this can be written as pH, okay. We can write this as pH. So, EMF of hydrogen electrode E cell is equal to minus 0.059 pH, right. So, if we know the pH value, that means that is what is our heading, EMF of hydrogen electrode at different concentrations of H plus ions. Different concentration of H plus ions means different pHs. By knowing the concentration of H plus ions, we can measure the pH. So, and we substitute the pH value corresponding to the concentration of H plus ions, we can get the E cell of hydrogen electrode, right. Now, we shall see the problems. You should remember this formula, that is EMF of hydrogen electrode at different concentrations or at a different pH is equal to E cell equal to minus 0.059 pH, right. You should remember that formula. Now, we shall go for one or two problems. Okay. The problem is if the presence of hydrogen gas is increased from 1 atmosphere to 100 atmosphere, keeping hydrogen ion concentration constant at 1 molar, then EMF of hydrogen half cell at 25 degrees centigrade will be, right. What we to find is EMF of hydrogen electrode. What we require to determine is that EMF of hydrogen half cell at 25 degrees centigrade will be. So, you should write the half cell reaction, hydrogen half cell reaction. What is that hydrogen half cell reaction? 2H plus 2 electrons gives rise to H2 gas, This is the electrode reaction for hydrogen electrode, and we can measure. Already I told you EMF of hydrogen half cell. We can measure the EMF of hydrogen half cell with the help of Nernst equation. What is that Nernst equation? E cell equal to E naught cell minus 0.0 or 0.059 n log k. This is the equation. I can write this as a basic equation, that is E cell is equal to E naught cell minus 2.303 RT by NF log k. This is the Nernst equation. Okay, whenever we write 2.303, the log, this is the Briggscian logarithm, that is the base 10 logarithm. Whenever we cannot write 2.303, then we should write ln, that is Neperian logarithm, right. To discriminate that two, I write this entire Nernst equation, and we can write this E naught cell minus 2.333 RT by F, that is 0. That equal to 0.059 by N log K. This is the equation for EMF of hydrogen half cell, right. So, already I told you that Nernst equation enable us to find the EMF of the cell by taking E naught cell 0, by taking E naught cell 0. So, we shall take E naught cell 0, E cell is equal to E naught cell 0, E naught cell is 0 minus 0.059 n where the number of electrons transferred is 2 log, here the K is equilibrium constant. Equilibrium constant, how can we write this equilibrium constant? Partial pressure. Here the product is hydrogen gas. Hydrogen gas is usually expressed in partial pressures, that is partial pressure of H2 by concentration of H plus square, right, concentration of H plus square. So, what the final equation is, E cell equal to minus 0.059 by 2 log partial pressure of H2 by concentration of H plus ions square. So, what the given data is, here the presence of hydrogen gas is increased from 1 atmosphere to 100 atmosphere. Actually, the partial pressure of H2 is 1 atmosphere, but here the 1 atmosphere pressure is increased to 100 atmosphere, keeping the hydrogen ion concentration constant at 1 molar, right. So, we need to substitute that values, minus 0.059 by 2 log partial pressure is increased from 1 atmosphere to 10 atmosphere, 100 atmosphere. 100 atmosphere, we can write that 100 atmosphere as 10 square, by concentration of H plus ions is kept at constant, that is 1, concentration of H plus ions is 1 square, right. So, 1 square means that becomes 1, and minus 0.059 by 2, this can be written as 2 log 10, 2 log 10. This 2 cancel, and the log 10 is 1. Therefore, EMF of the cell is minus 0.059. So, E cell of EMF of hydrogen half cell at 1 atmosphere at 1 molar concentration of H plus ions, and at 100 atmospheric pressure is E cell equal to minus 0.059. Okay, in this way we can solve n number of problems based on this concept. Okay, now we shall go for another problem. Okay, and the next problem is for the EMF of hydrogen electrode to be 0, the presence of hydrogen required in neutral pH is, right, in right. So, we need to calculate the EMF of hydrogen electrode, and that should be that is to be 0, and the presence of hydrogen required in neutral pH is, okay. So, we need to write the hydrogen electrode half cell reaction, that is we know that the hydrogen half cell reaction 2H plus 2 electrons gives rise to H2 gas, right. So, that is the hydrogen half cell reaction, and we need to calculate the EMF of hydrogen electrode. EMF of the hydrogen electrode can be calculated by using Nernst equation. What is the Nernst equation? E cell equal to E naught cell. So, what is that Nernst equation? Simple Nernst equation, E cell equal to E naught cell minus 0.059 by N log K, right. So, we need to in the determination of EMF of hydrogen electrode, we always take E naught cell as 0, right. So, E cell is equal to E naught cell 0 minus 0.059 by, where N is number of electrons transferred, that is 2 log K means partial pressure of H2 by concentration of H plus square, right. Then E cell is equal to minus 0.059 by 2 log. Okay, here the presence of hydrogen required in neutral pH. Okay, they gave that neutral pH, that is they given that concentration of H plus ions. Neutral pH means pH equal to 7, then concentration of H plus ions is 10 power minus 7. They gave that concentration of H plus ions is 10 power minus 7 molar, right. So, we need to substitute that value, that is we need to calculate the presence of hydrogen required in neutral pH. So, presence of partial pressure, we need to calculate the partial pressure of H2. Okay. So, concentration of H plus ions is 10 power minus 2 minus 7 square, right. So, now this equation is E cell is equal to minus 0.059 by 2 log pH2, partial pressure of H2 by concentration of 10 power minus 7 square. But they given that EMF of hydrogen electrode to be 0. Okay, they gave that EMF of hydrogen electrode to be 0, that is they are that from that statement we can take E cell equal to 0, E cell equal to 0. So, EMF of the hydrogen electrode is to be 0. If that EMF of the hydrogen electrode to be 0, then what is the hydrogen ion, then what is the presence of hydrogen is required to calculate. Okay, what we require to calculate is presence of hydrogen when EMF of the hydrogen electrode to be 0. So, from that statement we can equate this, we can write the 0 instead of E cell, that is minus 0.059 by 2 log partial pressure of H2 into 10 power minus 7 square. Okay. So, from this equation we can write log partial pressure of H2 by concentration of 10 power minus 7 square is equal to 0. By equating the 0, we can write this equation log partial pressure of H2 10 power minus 7 square equal to 0, right. In the next step, we can write the log 0 as we can write that 0 as log 1. We can write that 0 as log 1. So, log partial pressure of H2 by concentration of 10 power minus 7 square is equal to log 1. In the next step, log gets cancelled, partial pressure of H2 is equal to 10 power minus 7 square, that is 10 power minus 14. So, partial pressure of the presence of hydrogen would be 10 power minus 14. So, in this way we can calculate the EMF of hydrogen electrode. Okay, you should remember one point, in all EMF measurements we always measure the difference of potentials of electrodes. Okay, but when we need to calculate the EMF of hydrogen electrode, we need to take the E naught cell as 0. Okay, I hope you all understand this lecture. If you are really like this lecture, please extend your support by like, comment, share. Thank you for watching.